All right, day number 2 here. Hopefully you've already had a chance to do the 5 questions from day number 1. So here we go. Number 2. We've got finding values for each variable here. So we've got some special right triangles. We got 30, 60, 90, and then 45, 45, 90. Now I do notice that they're giving me the side length that is across from the 30-degree angle. That's probably the most straightforward you'll see with the 30, 60, 90. So this z, which is across from the hypotenuse, is going to be that 9 times 2. So z is going to be 18 units. Now, it's not a variable, but I do need it to continue in the question. I do need to figure out what the side is that is across from the 60-degree angle. All right, so that side is going to be that 9 times, and that's going to be times root 3 to find that side length. Okay? Now, to move from the hypotenuse in a 45, 45, 90 to one of the sides, which we know they'll be the same, I do need to divide by the square root of 2. So x is going to be equal to 9 root 3 divided by the square root of 2. Now, I cannot leave it like that. I do need to multiply by root 2 over root 2 to simplify those radicals. So that's going to be equal to 9 root 6 over 2. And then just check to make sure you can't reduce anymore. 9 over 2 cannot reduce. So x is equal to 9 root 6 over 2. Now y is actually the same as x. So it is also 9 root 6 over 2. All right, so that's it for the first one. Number 2. Now, number 2, we have these segments, angles. We got with the circles, with our secants and tangents and all that. Check that theorem sheet out. Remember, you're not going to be able to ask us any questions about where stuff is on the theorem sheet. So please make sure you know where to look for these different questions. So the first thing I'm going to do is to write an equation with letters, right, from my figure before I plug in anything, right? I don't want you guys to lose credit for things that should be hopefully points that you should get. So we have the measure of this angle here, which is angle TUV, is equal to 1/2 times the measure of arc SW minus the measure of arc TV. Okay, don't forget the arc notation as well. Now you can plug in this stuff from the problem. So we have 6x minus 19 equals 1/2 times the measure of arc SW is 12x minus 5 minus, and be careful here, right, because I am subtracting. I need to put this measure of arc TV, this expression, in parentheses. So 2x plus 7 is going to be in that parentheses. All right, I'm going to simplify inside those parentheses. All right, 12x minus 2x is 10x. Now here's where you'll make a mistake. So if you need to take an extra step and distribute the negative onto the 7 as well, please do that. My brain does -5, I'll highlight it for you, -5 minus 7, right? And so -5 minus 7 is a -12. But please, 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 feel free to distribute the subtraction so you can end up using the addition. Okay, so now you've got options here. You can distribute the 1/2 into the 10x minus 12. That is what I'm going to do, because 10x and 12, those are both even numbers, so it will be simple to do that. But if you want to move the 1/2 to the left side of the equation by multiplying by 2, that's also fine. You would just get 12x minus 38 on that side. All right, so it's your call. You should get the same thing. So I'm going to distribute the 1/2 to get 5x minus 6. All right, then I'm going to subtract the 5x over to get 1x, right? 6x minus 5x is 1x. Move the minus 19 with addition, and -6 plus 19 is going to be 13. So x is 13. Now that's not what I have to finish the question with. It does say to find the measure of arc SW. So I'm going to write down the measure of arc SW, which was 12x minus 5. And I'm going to plug in that 13 where it says x. All right. And if we do that math, I know 12 times 12 is 144. So adding another 12 would give me 156 minus 5. So the measure of arc SW is equal to 151 degrees. All right, so that is it for all the work in number 2. Okay, let's go to number 3. All right, we're going to use our calculator for this one. It says if the sum of the interior angles of a polygon is 2,340 degrees, how many sides does the polygon have? So I'm going to write down from my formula sheet, right, n minus 2, so the number of sides minus 2, times 180 degrees equals, All right, the sum of the interior angles, which they gave me in the question, 2,340 degrees. Now you can feel free to distribute the 180 onto the n and onto the -2 and then go from there. I actually am going to move the 180 over with division first, because then that would just give me n minus 2 equals whatever this is. So I'll go to my calculator and do 2340 divided by 180, which is 13. All right, now be careful, that's not the answer, right? That's n minus 2 would give me that answer, so the number of sides needs to be 15. So this polygon has 15 sides. Okay? All right, let's go to number 4, another calculator one. All right, so calculator one here for number 4 says find the area of a regular polygon. So I know from my formula sheet, I will be using 1/2 times the apothem times the perimeter. All right, so first I need to figure out what that apothem is going to be. So feel free to draw it in the figure or draw a new figure for the triangle. It's your call. I'll do both just to make sure we're good. So I've got here, right? Either one. You don't have to do both, just pick one. Now this is a regular hexagon, 1, 2, 3, 4, 5, 6 sides. So if I do my n minus 2 times 180, I have 6 minus 2 times 180, so that's 4 times 180, which is 720, and then divided by 6 gives me 120 degrees for all of these angles, okay? And so that means when I draw this radius here, that's going to split this into 60 degrees. So this is going to be a 60 and 30 and 90 right triangle. Now be careful here, when I draw that apothem straight down in my regular polygon, it's going to split this to be 11 yards. Now I want to find the apothem, which is here. That is going to be across from the 60 degree angle. So I'm going to take my short leg, that 11, and multiply it by √3. So the apothem is 11 √3. So now I can move to my formula to plug in my apothem, which is 11 times the square root of 3. We do need the perimeter, which is going to be 6 times that 22 yards, right? We have 22 yards, there's 6 of them, they're all the same. So 22 times 6 is going to give me 132 yards. So I will be plugging that in for the perimeter of this polygon. Then I'm going to get an exact answer, and then I will round with my calculator. So I did 132 times 1/2, so half of 132, that's going to be 66 times 11 √3. And then 66 times 11, that's going to be 726 times √3, because I don't need the parentheses anymore. There we go. All right, and then so I'm going to go to the calculator to do 726 times √3 times square root of 3. So approximately 1,257.47. 1,257.47. We are finding the area here, so this is going to be yards squared. Okay, that's it for number 4. All right, last one. A surface area question. All right, so trying to figure out, I think the biggest thing here that we'll be checking for your work, like the quiz 8B, or our last quiz that we took, is to try to find the surface area of the figure. Let's set up what we're going to need to figure out. So I'm going to choose the surface area of the cylinder. All right, that is going to be kind of the base of what I'm doing. Plus, then I don't want to include the bottom of that cone, so I'm going to do the lateral area of the cone. But you can see that the cone is sitting on top of the cylinder, so I cannot include, this amount. That would be too much if I stopped here. So I'm going to subtract out the area of that circle. All right, so that's kind of the first thing I want to figure out before I start putting in formulas. So go into the theorem sheet. You can find that on your theorem sheet and write down our formula. We have surface area of the cylinder is 2 pi r squared plus 2 pi rh, plus the lateral area of the cone is pi times the radius times the slant height minus the area of a circle, which is pi r squared. Now I pretty much have everything. The only thing I don't know yet is I'm going to make this also 3 feet. So I really need to figure out the radius of that base of the cone. So if I look here and here, right, 3 and 3 on each side, that's 6. I do see this 20 feet. So subtracting that 20 minus 6 gives me 14 feet. So the diameter is 14 feet. So I'm going to choose 7 feet for the radii there. Okay. So now we can plug in. We have 2 times pi times the radius. Now I'm doing, this is the cylinder. So this radius here is going to be 10 feet. So I'm going to plug in 10 squared plus 2 times pi times the radius of 10 times the height of 6 plus pi times the radius for the cone is 7 times the slant height is 8 minus pi times the radius of that circle is going to be 7 squared. All right, let's get some numbers here. We have 10 squared is 100 times 2 is 200 pi plus that's 60 times 2 is 120 pi plus 56 pi minus 49 pi. So I'm going to get an exact answer with pi, and then I will use my calculator. So that's, let's see, 320, 376 minus 49 is going to be 327 pi. And so if I want to get an approximate, I'll go to the calculator to do 327 pi. So approximately 1027.30. 1027.30. We are doing surface area, so it's going to be square feet. All right, guys, so that is it for day number 2. Again, check back to Canvas to look at days 3 through 5, and then come see us on Wednesday for any questions. Good luck.